Our next speaker is Serrie Chapman. Serrie's currently working at Infineon UK as requirements manager.
Right, is it?
Her talk is on the intelligent requirements engineering.
Or lack of it, I think.
Or lack of it.
Right, yeah. I know that everybody knows this subject. It is quite a complex subject. It seems simple because I know that a lot of managers at Infineon keep picking it up and saying, oh, I'll run with that, and then looking at how much work it takes and then running away from it very quickly and leaving it with me every time. So basically, we're just going to go through some of the experiences that we've had. We've just, okay. First of all, I'll tell you about me. I'm a bit of a magpie here because we are with hardware, but there are some of my colleagues out there, so I'm not the only one. Infineon Semiconductors, we're a big German company. Formerly, we were Siemens Semiconductor, but we came out there in 1999. We are in the #1 market position, semiconductor discretes and modules for power electronics. ARIX is our current product family, and this is what I've been trying to do requirements engineering on. It is actually, there's 2 product families, and there's a total of about 15 chips in there with at least 80 modules on each, all of which need to prove requirements engineering proofs. It is a brand new brand out of there. The first 65 nanometer is currently going out, and its multi-core architecture is based on up to 3 independent 32-bit tri-core CPUs. Over 50% of all new cars worldwide have a tri-core going out in them, and it's actually designed in Bristol. The Bristol design site is about 50 engineers, and 30 of them work on tri-core, so it's a very small R&D group. But we have been doing it successfully for a few years now. So requirements engineering, why would we do it? I think most people have been listening to the shift to left, etc. If you look at Spirit Consortium and etc., for years they keep saying automate more down the flow, but if you do, you've got to go up to the top and have a look at your requirements, and it's not a good site. I can assure you it's not a good site. You can get better time to market if you do a first time right, if you get your requirements correct. One of the issues we've got is we have multiple customers. The customers do not want to give us their proper requirements or use cases because they don't want their competitors to know them. So we have to almost do a guess, which causes us a lot of problems because we then got to look for conflict analysis, and that's very difficult to do within requirements. You can also improve process visibility. When you start looking at requirements engineering, you can start looking at who's doing what. You've got much more visibility throughout the flow, and you can also start to improve the quality of your product because you try to make it more complete for what your customer wants. And you also start to look at your internal requirements, which are often overlooked. Impact analysis, cost of change and feature creep. This is all coming through your change management system. Your customers just suddenly decide that one of the things you haven't read correctly, could you quickly change that? If you've got proper requirements engineering in place, then you should quite easily see how much that's going to affect everything if you make a simple change at the top. And you'll also be very aware of your feature creep in your requirements. So you should start charging in your customers for these late feature creeps. They should tell you what they want up front, not tell you that that's not what they want at the end, which is what we do tend to get. Improved documentation. It's all about documentation, I'm sorry, but it really is. You've got to ensure auditability. You've got to ensure that your documentation is there, or else you cannot link down and do a requirements tracing at all. So the question is, why did Infineon finally get around to this? I mean, I've been looking at it since 2004. We've agreed that we had the ideas there. You'd think it was a great management decision, but it wasn't. A new standard came in. The ISO 26262 is a new functional safety standard. I think it came for the 16509, and they've just tightened it up. It's currently for under 3.5 tons. There's a further one coming out for over 3.5 tons, and I've noticed that Volvo have done a lot of upfront work ready for the new standard that hasn't even been published yet. It has scared the automotive industry no end, because if you think that software don't like doing documentation, I can assure you that hardware don't either. If you look at this, the big red thing there is the requirements traceability. The code, the actual safety doesn't say. It is about a risk reduction, but it actually doesn't say, can you prove requirements traceability, or can you give me a safe system? Because I could say that, yeah, Bob told me it was safe back in '94. Yeah, he was killed in a crash afterwards. But, you know, we've got maintenance for 30 to 40 years in these cars, and I've got to go back and prove that what we were doing at the time was first time right, that we were doing the proper stuff. So if we look at a requirements traceability tree, we have an upstream and downstream. We start off with our requirements, so we get stakeholders, internal and external, other product requirements. We then get, well, there's a lot of problems within requirements engineering is that we use words like validation, verification, and testing, and everybody uses them slightly differently. There's a lot of work ongoing in some of the funding projects I'm in about ontology, but it will take us years of our lives to get the ontology sorted out. So I tend to use generic terms such as we intend to implement a certain requirement, we intend to verify or intend to prove implementation, and then that we have a proof of implementation, which could be software, hardware, formal, random, like Giles was showing you earlier. And if we look at some of these documents, our ITS alone is 10,000 pages, and we've got to somehow link that up to our requirements. So that's the state space. I found this picture on the net. I looked up engineer and documentation and came up with Mr. Fletcher. So the problems, documentation and documented proofs and arguments. The standard does not tell us to just document. It tells us to give us a valid argument that we are sure that that requirement has been implemented. And you'll find that your engineers don't like writing documentation. So the tooling to do requirements engineering isn't difficult. Ensuring that the correct documentation and the correct linkage is difficult, because one thing, you'll get 50% of the people that you're working with will read your instructions and come out first time right with putting in your tagging or whatever you use to link. There'll be a 50%, a 30% who probably just do it accidentally wrong. There's 20% who will do it wrong because they don't like doing it. They don't want to do it right. So if we go to, I'm sure most of you have seen this one. These people all need to link their requirements. The requirements are coming from the customer, and they actually get translated through the analyst, etc., and how people wrote it. But if you look at the bottom left, how the project was documented, and that's quite true for most of the industry, it's very difficult to get any documentation out of people. And when they do, one of the things that requirements engineering has driven us to is that it started to make us think more about our documentation and how it links up. What we do find we're doing is we're losing context. That if something's at a certain hierarchy at the top level from the customer, it can change name inside the internal target spec, it can change name inside the group that are verifying it, and it can change context. The minute you start changing hierarchies along your flow, you can lose context, in which case you end up verifying something that was never a requirement. So the other problems, I did say I was going to have a whinge. We have poor quality requirements, incorrect tagging. We have a tool where you have to tag, so you have to say, because you still have a manual process, that you have to say that that requirement will be covered by this that I've written in this document. It's a manual process. I spend about 50% of my time correcting those. Document dependencies. A lot of the problems that we've seen is that if you're going to tag one document to another, then that first one needs to be ready first. So the product requirement document means no more change requests. And I don't know whether many people here have ever dealt with a product requirement document that actually came to them at the beginning of the project and did not change. I doubt it, because this is my problem, is that I'm trying to link and cover a document that's completely moving throughout the flow. Managing change. We've been using change and configuration management systems for years, so I thought we'd be okay for this, but unfortunately, we started looking at that. The changes from the customer come through our change system. Now, a requirement should be atomic, unambiguous, verifiable, feasible, etc., etc. You've got a whole list of what makes a quality requirement. In the change system, somebody will write, make a change to the product requirement document. Pete said that the customer didn't like that. You know, I have to then work out what they mean and how I'm going to translate that into a positive requirement and actually make the change that it's asking for. Integrating tooling within a mature system. First time around we did, let's see what tools we've got in the company and let's use them all to implement requirements engineering. I would suggest that if anybody's starting, don't go and look for what your actual requirements are and look for the best tool. Linking old tools together is not that easy. It is very problematic, and we've seen the way forward when we've been constantly improving and we've got new tools coming in. which will solve a lot of my problems, but I've manually been working a lot of overtime to solve this. The other problems you have is the standard requires that you have to put processes in place. So if you haven't got automated tooling, you must have a process written down, must be under configuration management, must be there in 20 years' time. You're going to have to communicate those new processes. So you're then reliant on managers communicating them and then showing the discipline for them to do it. And the lack of time and resources, both on my side, on my tooling side, and on the engineer's side, it's difficult because you're trying to get them to discipline, and yet it's very difficult to communicate to them, and they don't want to do it. Most of my time is spent in support, and that was the only way we got through it, was that I just said, right, I'll do it for you. So basically what we're looking to improve it is, and we're working with there's a couple of EU projects that are looking at requirements engineering and interoperability. They're looking at an interoperability specification in an Artemis project called Crystal, which has just kicked off, and it's a follow-on from a requirements engineering project called Caesar. One of the things they're looking at is a common language with stakeholders. Our customers are asking us for a common language. There is one out there called RECIF. However, it seems to have been picked up and then dropped. This group of 71 consortium partners, European group, are looking at what we can do to improve that. Within Infineon, we've written our own, but we want to make sure that we can put it within theirs. Add a clear hierarchy, because I said your hierarchy changes and your context changes during the flow of the process. You need some kind of lookup table to say what matches what. One of the new tools we've got, Visual, I'm not selling them, but it's a good tool, and it links with the change management system, but it has a lookup table. So if it means X here, it means Y there, you can tell it that. We don't have that currently with our tooling, so it loses context. Write a clear set of internal requirements, link them to the external, and use a tight notation rule set. The whole point of this is that what we realized is the first time through we ran the customer requirements, they were rubbish, absolutely rubbish. We investigated about 3 of them, just had a look at them, and they had 7 or 8 requirements within each requirement, and they were at different ASIL safety levels. And we were just trying to link those down, which didn't make sense. We didn't think it through. We were taken aback by it, I would say. So this time around, what we've done is we've spent a lot of time up front doing the shift left, which Jim suggested, but that was after we'd already done it. So we have shifted left. We've just spent 3 or 4 months with 20 people writing a clear set of internal requirements. We can then link these for a traceability matrix to the customer one, so therefore we can then use attributes and give the customer their documentation without seeing each other's, and not just saying, yes, we're going to say yes to you, we're going to say yes to you, and we've implemented all of these features to cover that requirement. It's not going to deliver us the common language at the top step, but it's an interim measure, and I'm hoping it will work. Translate requirements for reuse. If you've written a good atomic requirements with a good syntactical constraint, there's no reason why you haven't got all the information in there to give you your black box test list or your feature set for your documentation. Reuse it. I don't see any reason why you can't do some more automated tagging, reuse it. You get your black box test list within the tooling. You can then refine that and say, yes, I need to test this particular feature and I'm going to test it with these. So start using it that way. So we had a lot of issues with the fact that the documentation that we had to link. One of them goes through a flow for approval, which is what we need for the auditing. However, the tooling wouldn't support it. If you are going to use disparate files and you're going to produce requirements reports, you need to say what file it was, and you need to say that, for example, for ours is all XML driven, but that's not what we're signing off. We're signing off a PDF. So we have to have metadata to say that PDF was produced by that XML, which has been linked into our requirements system. And use configuration management properly. All of our guys work within Linux. Now, they would never dream of checking out an entity, changing its name and checking it back in each time with the version number. But with documentation, they do. But I've got a path to one document. If you check it out and then say version 1.3 now, it doesn't make sense. Stick it in the metadata. The metadata is there to be used. Centralize the documentation. If you can, get everything into a proper requirements tool. The only issue there is probably your proof of implementation, i.e. your test results. I know that we've got one business unit currently looking into that solution. Choose the correct tools for the scale of the project. I mean, I am talking thousands of documents that I have to look after and 400 people that I'm dealing with. If, however, it's just Jim and Bob and you've only got 5 requirements, don't go out and buy a big tool. You know, just stick it somewhere in 2 Excel sheets and do a review. That's fine. We can't review because we've got 5,000 plus requirements. It's a big job, so we have to automate as much as possible. Defining the leaf nodes, the requirements tree. Where is your proof? I mean, if you've got a requirement that says you must have an FMEDA document, you don't need to go downstream of the FMEDA. You don't have to prove any further than that because your proof is that it exists. That's it. So you have to understand that a leaf node is a leaf node and doesn't require any more covering. Our tooling guys didn't quite get that for us. And this is probably the last and most interesting from this perspective, is we've started to implement a requirements-driven verification and test methodologies. Some of the things that we found is that for proving implementation, we have random, assertions, formal, lots of different types of proving implementation. What we found is for things such as the random, as you said, as they was shown earlier by Caveritas, is something that you don't really know which state space you've been in because you're allowing it anywhere. So then you have to say, well, if I've got a requirement and the test is that X plus Y equals Z, how do I know that I've hit that in a random test? And I don't. The only time I know it is if it's failed, because you normally have a checker that says X plus Y equals Z, else fail. So then you have to put a checker point on it and say, check that you've actually exercised that piece. So that's the functional coverage side of things. And what we've been working with random constrained for years, and one of the problems is we don't know when to stop with how many functional coverage points to write, because they all cost us time and money. But if you actually get your requirements complete, then surely you should only be putting them in for what is required. And if your designer is asking you to turn around and implement or test anything else, you have to go back up to change management and say, they're asking me for this. Is this a missing requirement, or is this over-engineering? Because over-engineering is a massive cost to us as well. So I think that's it. Fun topic.